Hello everybody and welcome to this Easy 11 Plus live lesson on clock problems in maths, and an especially big welcome to all those people who are excitedly commenting, wondering whether I'm going to make another mistake today. Let's find out. If you like this video, especially the mistakes, please click like and subscribe and the bell button. And remember that, as always, the worksheet is linked in the video description underneath. I apologise if there's a bit of lag on the video today. I'm having a few problems with my broadband. Hopefully they will be sorted within the next few weeks. Okay, let's get started with today's lesson. Most of you have probably already seen the worksheet and you've probably already seen this question. It begins with a lot of background information, which is basically defining what a clock is, which you know. It's a 12-hour clock and it's a clock with hands. And that's what we're going to be dealing with today. Clock problems are kind of niche, but they're actually really common in the 11 Plus because they're a really fantastic way of testing knowledge of angles and how things move relative to each other. So let's start off nice and gently. What angle does the minute hand, very important, don't misread that, of a clock pass through over 45 minutes? Okay, this should be dead simple, I think. It's kind of a warm-up. So let's just do a quick sketch. You don't always need to draw a full clock when you do these things, but I do recommend always sketching. So that's where it starts. If we imagine it starts on the hour, and then it ends over here. So it goes around this angle, not this angle, because the clock isn't moving backwards. And it's good to draw in some lines to break this up. So we can see that it passes through 180 degrees here, and another 90 degrees here. So we add those together, 180 plus 90 equals 270 degrees. And it's as simple as that to get us started. Now, I'm assuming that you've got a basic knowledge of what degrees are and how they work, but perhaps it's useful just to do a quick reminder. Let's use this space just for this purpose. So if you've got a complete circle here, if you go all the way around from there to there, you have gone through a turn of 360 degrees. Don't make one of the most common and the silliest mistakes in maths, just the kind of mistake that I would make, and imagine that there are 365 degrees in a circle. There are 365 days in a normal year. It can easily confuse you, but it's completely different. And coming from this fact, we therefore know that in a half turn, there are 180 degrees, and in a quarter turn, there are 90 degrees. And if you've got an angle of 90 degrees, you can also mark that like this. And that's called a right angle, and that means it's 90 degrees. And I'm sure everybody watching knows all that, but it's worth just doing the quick revision for anybody who doesn't. One quick thing actually as well. Why do we even use degrees? What's the point of calling that a 90-degree angle? Why can't we talk about centimeters, for example? Well, the reason's dead simple. You could go through 90 degrees down here, and let's say that that's, I don't know, 1 centimeter. And we could go through 90 degrees up here, and that might be 5 centimeters. So the distance is different depending on how near you are to the center of the turn that you're making. Whereas if we talk in degrees, it's always consistent. So it's a very useful way of describing turns between lines, essentially. Right, let's push on. What angle does the minute hand of a clock pass through in 18 minutes? Okay, so we're going to do just the same sort of thing, but this time I'm going to sketch a little bit of a clock just so we can work out reasonably accurately where 18 minutes are. When you're doing sketches, they don't need to be precise, but they do need to be clear enough for you to understand what's going on and for somebody reviewing your working to understand what's going on. By the way, I'm hoping that the sound is a lot clearer this time. I've got myself a new microphone this week, so hopefully the sound won't cut. And hopefully it'll sound a lot clearer and easier to understand. Do let me know if whether that is or isn't the case, because it's useful feedback for me. I am keeping an eye on your comments. Sanjay Singh says, why do you use degrees in Celsius, Fahrenheit, and Kelvin? A degree is a common word in English that means a little movement, a little increase or change. And so it's used in lots of different contexts, but a degree for temperature is a completely different thing from a degree for an angle. It's just the same word in a different context. That's a fantastic question. And thank you for the comment saying that the sound quality is much better. Just adjusting something there. Okay, anyway, back onto this. I always get distracted and waste time, sorry. If I was teaching in a school, I'd be one of those teachers who people just say, by the way, sir, what about this thing? And then I talk for the whole lesson and you wouldn't learn anything. But this is a different context, so exactly the same thing happens. Right, okay, so we've got 12 at the top and 6 at the bottom. I'm just going to sketch some times in here. Okay, right, so in 18 minutes, so the minute hand starts up here, and it ends up somewhere. 20 minutes would be here, of course, 15 minutes would be here, 18 is a little bit nearer to 20, so in our rough sketch it's going to end up about there, and a rough sketch is all we need. It just needs to be adequate for our purposes. Right, so we can see that if we go this far, that of course is a right angle, 90 degrees. Again, I'm assuming a bit of background knowledge. Now, what we need to concentrate on here is this area down here. What angle is that? Well, if we know that this full quarter circle is 90 degrees, then each hour, as it were, so 3 to 4, 4 to 5, 5 to 6, there are 3 of those, that's the third of 90 degrees, so each of those must be 30 degrees. This isn't a very official way of marking angles, but it's useful for our purposes because it keeps these notes well out of the way of the middle of the diagram where we want to be doing some more detailed working. Anyway, we know that 3 to 4 o'clock, as it were, or 15 minutes past to 20 minutes past, more relevant to what we're doing, is 30 degrees. Now, there are 5 minutes in there, so each minute is going to be a fifth of 30 degrees. 30 divided by 5 equals 6 degrees. Okay, know your times tables, really important, as I've said before. And here, going from 15 to 18 minutes past, we've gone through 3 minutes, and 3 times 6 equals 18 degrees. So we got 90 degrees plus 18 degrees, which gives us, of course, you were there hours ago, 108 degrees. Look, I know this is simple, but the important thing is to get the hang of the method and the way that I'm showing this, because it'll be very useful when the questions get a little bit trickier. Okay, onwards. What angle does the hour hand of a clock pass through in 10 minutes? Ah, well, this is dead easy, because we go from there and we go to 10 past, and of course that's a sixth of an hour, so a sixth of 60, hang on, not minutes, degrees, a sixth of 360. Okay, so, but hang on a sec, yes, I've done this on purpose for my good friend Sanjay in the comments, who doesn't like me referring to him, but who loves my mistakes, because here I've deliberately made exactly the mistake that I warned you about earlier on, because you need to read the question and it refers to the hour hand of a clock, not the minute hand. Now, a minute hand will, of course, go through a sixth of 360 degrees during the course of an hour. But the hour hand of a clock starts off pointing up here at 12, if we imagine it starting at 12, just arbitrarily, it doesn't matter where it starts. Let's do a 3 over here, and a 1 and a 2. And it ends up just here. So in 1 hour, the hour hand has moved through a 12th of 360 degrees. Or, to make it easier based on what we're seeing here, we can see that this is a right angle. So it's gone through a third of 90 degrees, otherwise known as 30 degrees. I'm not going to write all that working out because the fact that it's 30 degrees is the kind of knowledge you're allowed to take for granted. Okay, so in 10 minutes, it's going to go through a sixth of that, because 10 minutes, these are useful notes in your working because they show what you're doing, help the examiner to understand that you know what's going on. 10 minutes equals a sixth of an hour. It's really useful for you, it's really useful for them if they're marking. It's also very useful if you make a silly mistake somewhere. Not that any of us, especially me, ever make silly mistakes, because then they can go back and give you marks for the other stuff that was good that you did along the way. 10 minutes is a sixth of an hour. We know that an hour is 30 degrees, and so we need a sixth of 30 degrees. 30 divided by 6 equals 5 degrees. And that's our solution. In fact, I'm going to do something terribly disorganized here because I think I could usefully show you another quick method for the previous one. This is awful lesson organization, but I think it's actually quite important. I forgot this while I was showing you, to be honest. Let's just get rid of this working here so I've got a bit of space. So there's another way you could do this, which is to say that 18 minutes is 18, oops, oh no, what have I done? I've destroyed the world. That's better. Terribly hot in this office. I'm going to be keeling over by the end of this. So we've got, I've had to turn the fan off so it doesn't buzz on the microphone, but that just means it's turning into a Turkish bath in here. 18 out of 60, which is the fraction we're talking about, 80 minutes out of 60 minutes, which would be an hour, of, and if you remember a previous lesson, this is something super important, pay attention to this, that of means times in maths, okay? So when you've got of, when we say 18/60ths of 360 degrees, that's a times. 18 over 60 times 360, okay? And we can write that as 360 over 1 because any number is itself over 1. And now we've got two fractions to multiply. We can do lots of simplifying here. First of all, when you're multiplying, just when you're multiplying, but it's very useful, you can always cancel diagonally. So divide by 10, divide by 10. 18 divided by 6 is, of course, drum roll, 3. So just kill that. 3 times 36 equals, I'm not going to do the calculation on the side, we know the answer already, of course it is 108 degrees. You could do that as mental arithmetic. 3 times 30 is 90, 3 times 6 is 18, add them together. Okay, so that's another good way of doing it if you're comfortable with the maths. You don't have to sketch a diagram. Right, back onwards, let's carry on through these questions. In fact, I'm just going to take a quick second to look at the comments in case you're saying anything useful, such as your sound has stopped or your video, we can't see your video anymore. The Chess Player 21 says, if you draw a real-ish clock, then you could use a protractor or not. That's an interesting idea. It's actually worth mentioning for a second. There's a slight problem with that. How would you draw a clock that was so accurate that you could then use a protractor? And the only way to do that, let's say you wanted to show 18 minutes, would be to work out the angles and then use those angles with the protractor to accurately draw the hands of the clock, which you could then measure. But you'd already need to know the angles in order to draw it accurately. So it just goes around in circles. You have to use a method like this before you could think about drawing accurately, besides which it would take you a long time in the exams. Accurate-ish is not good enough because in a question like this, you need the exact answer, not something that's kind of close to it. So a really interesting idea, but not something that is actually practical. Thank you for introducing that because I wouldn't have thought to comment on it. Not a stupid idea at all, a very interesting one. What is the shortest angle between the hands of a clock at 20 past 4? What do we mean by the shortest angle? Well, if I just draw an arbitrary angle here, there are actually two angles here. There's this angle here, which is a short angle, and there's this angle here, which is a much bigger angle. Either of those would be an accurate description of the angle between these lines, but only one is the shortest angle. So that's what this here means. Between the hands of a clock. Okay, now I think this question is actually defined that we're talking about a clock with a minute hand and an hour hand. But in a question like this, you should assume that there is no seconds hand unless you've been given a clear indication that there is a second hand on this clock. Many clocks don't have second hands. If they do, they're a confusing factor. They're the kind of thing that an examiner might forget to mention. In this case, it doesn't matter anyway because the second hand... no, it would matter. I'm talking complete nonsense. Yeah, it's a good thing there isn't a second hand. That was my mistake. Okay, right. Yes, thank you for the people who are naming these kinds of angles in the comments. That's absolutely brilliant. Okay, shortest angle to hands clock at 20 past 4. So the first thing we should do before we worry about any detail here is to do a quick sketch. So the same kind of thing. I'm just going to draw on the numbers that I need. 12, 6, 3, 1, 2, 4, 5. I'm not doing anything over here because I'm not going to get over there while I'm sketching 20 past 4. Now, the hours hand's is going to need a bit of thought, but 20 past is easy. We just point straight at the number 4, right? Now, at 20 past 4, the kind of common mistake that people make is they point the hour hand straight at the 4 and they say, oh, there's no difference at all. But of course that's a load of nonsense because, oh, my rubber is not working. It's all going wrong. Well, I can draw, I just can't rub out. Oh, I can rub out, lovely. Technology. Right, the point is that the hour hand also moves. So what we need to think about first of all is what has the minute hand done in these 20 minutes? Well, we could do lots of working out, but I think you're clever enough to see that it's gone a third of the way round the clock face. So the hour hand is also going to have gone a third of the way, but not a third of the way around the clock face, a third of the way between 4 o'clock over here and 5 o'clock down here. So the hour hand is going to be pointing somewhere like this. And that's what your clock looks like if you go to 20 past 4. Why am I repeating myself? Because that's what I do. It's all I have to offer to the world anymore. Right, enough waffle from me. So, let's make sure I'm not doing something utterly bonkers, but no, I don't think I am, for once. Okay, this is actually quite simple. So we already know that this here is 30 degrees, right? I'm not going to work that out afresh. It's a third of 90 degrees. You're allowed to take that kind of knowledge for granted. You can just show that is 30 degrees. It's a good bit of basic knowledge to know that between 2 hour positions on the clock is 30 degrees. And we also know that the hour hand has gone a third of the way between 4 and 5, because as we said, 20 minutes is a third of 60 minutes. So a third of 30 equals 10 degrees. So the answer is 10 degrees. It really is as simple as that. So it's a question that looks quite complicated, but when you sketch it and apply some basic knowledge, something pretty straightforward comes out of it. What's next? I should know what's next. I set these questions, but welcome to my world. What is the angle in degrees between the hands of the clock at the following times? Okay, well, we can see straight away here that we've gone through, let's do some sketching, 3, 4, 5, 6. So this here is 90 degrees. That's a right angle sign, that means 90 degrees. And this here is a third of 90 degrees, so that's going to be 30 degrees. So 90 plus 30 equals 120 degrees. Now, you might know that a third of the way around a clock face is 120 degrees. It's kind of elementary knowledge once you've got used to doing angles. However, it's always good to show a bit of working in an exam. So I strongly recommend that even if you just know that the answer is 120 degrees, quickly take the time to do something like this business here, at least with the right angle and the 30 degrees, and show yourself adding them together, and then you've got clear working and the answer, and nobody could find any fault with this at all. Someone says, if the minute or hour hand is pointing at 3, is it 90 degrees? Well, it depends what you're saying, really. If you're saying that it's, you could have a 90 degree time with one of those pointing at 3, but for example, 12:15 would not be 90 degrees, because yes, the minute hand would be pointing at 3, but the hour hand would have moved on a bit from 12, so it would actually be a bit less than 90 degrees. So could you have such a time? Oh, that's an elementary question. No, actually, I doubt that there is. No, I don't think you could have a 90 degree angle with one hand pointing at number 3, actually, now I think about it. Okay, another mistake, Sanjay. You're on fire today. Right. I feel like I'm on fire. I'm so hot in this room. Okay, 1:30. So here, 12. This would be 3. This would be 1. This would be 2. Hang on a sec. We can see clearly that that the hour hand is exactly halfway between 1 and 2. How do we know that? Because it's something 30. It is 1/2 So if this here is a right angle, this here is half of a right angle. So it's going to be, it's going to be 45 degrees. Okay, which means that this here is the same thing. I don't know why I did it up there. I could just done down here. 45 degrees. And this here, of course, is 90 degrees, a right angle. So we add them together. 90 plus, sorry about my writing, you know it by now, equals 135 degrees. Keep turning over my answer pages just to make sure I'm not making silly mistakes, because I don't want to entertain you too much. and shatter what vestiges of credibility I have left. Right, okay, 10-10. Finally, we've got one that's a little bit trickier. Let's make this clock face really big so we can work on it more closely, because we're going to need some detail here. Unfortunately, you can't do this in exam paper, but it's very useful when you've got what I've got here. I'm going to make my pen a bit smaller so it doesn't become enormously thick here. Right, okay. So it's 10 past 10. So first of all, let's do a line up here. We don't even need to make it dotted, just to show the middle point here. So we've got 10 past here. That means it's going to be pointing dead at 2. We know that each 5 minutes, or each hour, depending how you look at it, is 30 degrees. So this must be 60 degrees. Okay, that's relatively simple. Now you might be tempted to look over here and say this is going to be pointing at 10 o'clock, so that's also going to be 60 degrees. But of course you would be wrong. Because, we've established this point, one of the basic things... oh, hang on. There's a fantastic question being fired off here. Which is, I'm actually going to zoom out for this because it's such a good question. Thank you to my... most persistent and insightful commentator. Does it say the shortest angle in the question or not? No. So the answer to the person who has said, why does it have to be... I said, why do you have to go clockwise? But I think what they mean is, could you give, for example, this angle here rather than the angle inside there? And the answer is that that should be marked as correct if you gave that angle. But don't try and be kind of smart aleck for the sake of it. If they ask for the angle between the hands, always assume you're going for the shortest angle, because it could be they've just forgotten to specify and they might not realize what you've done if they're not a very intelligent marker, or if they just want to get their marking done. So just do the obvious thing, but really good point. Thank you for pointing that out. I should have pointed it out, or indeed made the question clearer. Anyway, I didn't, so let's move on. Right, we've got 9, 10, and 11. So here, this is just going to be a little bit past 10. I've put the 10 in slightly the wrong place, or I've put the hand in the wrong place, but no matter. If we draw a line up to 11, that's going to be 30 degrees. And here's the line we draw to 10. I'm not bothering dotting them anymore. So our question is, what is this angle here? Now, at 10 past 10, the hour hand has moved on 10 minutes, of course. 10 minutes, as we know already, because we referred to this before, is a sixth of an hour. And we know that in an hour, you go through, of course, 30 degrees. So the hour hand has moved on by a sixth of 30. Oh, look, we've done this before. A sixth of is times 30 equals 5 degrees. So this is 5 degrees. So this angle here, of course, must be 25 degrees, because the total of that section is 30 degrees. So lo and behold, we have, zoom out a bit so this isn't too tweeny tiny in the end, we've got 60 plus 30 plus 25. What have I done? Oh yeah, that's fine. Equals 115 degrees. Yes, you could do a column addition, but no one's going to fault you for being able to see how those add up without needing to do that. So it's quite simple, but you have to be systematic and clear in the way that you set these things out. Right, let's move on. I'm trying to fly through at a reasonable pace here because there are quite a few things to get through. Okay, this is another classic question type that uses the same ideas but is just a tiny bit fiddlier. And if you got the right answer to this when you were practicing with the worksheet, well done. If you're rewatching this at a later point and you haven't tried this question yet, then I strongly recommend that you pause the video, print off the worksheet, or don't print it off, just you can see it on the screen, have a go yourself, and then see whether what you do matches what I do. There's more than one way of approaching this. I will show you mine, which I think is nice and straightforward. Okay, we're looking at a time between 6 and 7 o'clock. So between 6 and 7 o'clock, the hour hand is going to be pointing somewhere down here. And we know that we want, in fact, I won't do this here, I'll keep it well out of the way so I can do my working down there. We know that the hour hand is going to be pointing somewhere down here, because we know that 6 is here, we know that 7 is here. I've got my tiny pen again, let's make that bigger. Okay, now we want 70 degrees. Okay, quick check, that's 90 degrees, right? It's a right angle. So 70 degrees is going to be a little bit less than that, something like that. So if we're going over here, we're going to be looking at something like this, or something like this. And that's really, really useful for us to know, because if we know roughly what we're aiming for, we can get a really good head start with our working. Now, nobody's going to be expecting you to calculate this from first principles. It'd be pretty complicated maths. Instead, we're just going to use some simple trial and improvement. But the thing about trial and improvement is you need to be intelligent and working carefully. So, for example, if we were to try 6:15, let's do some quick notes. 6:15 over here. I'm just going to do a very rough sketch just to see if it's plausible. So the hour hand will be just past 6 o'clock, and the minute hand will be over here. And you can see that that is definitely a much bigger angle than either of these angles here. So 6:15 is not going to work for us. Okay, let's try another one. Let's try 6:30. So I think we can see from this it's not going to be 6:30, but let's just make sure so we can do our trial and improvement and working well. So it's 6:30, we've got the hour hand down here and the minute hand down there. That is definitely not, oopsie daisies. That is definitely not like this over here. Right, so it's not either of those, but it's going to be in between them. Okay, so what time between 6:15 and 6:30, and we should go for nice, decent sized numbers like 20, 25, something like that to start with, to see whether we get close. What time of those is going to be between these two here and closest to this? I'm not worrying about this over here yet. We can come to that if it isn't easy on this side. Let's work around the clock face. Well, I think we should be aiming for 6:20. That's a natural thing to try. So let's try 6:20. So at 6:20, now we know we're close, so it's worth sketching some numbers on our clock face. So I'll put no, I won't bother with a 12, just a 6. Here's the center of the clock face. Here's 6, here's 3, 4, 5. Again, doesn't need to be accurate. At 6:20, we always start with a minute hand, because that's the one that we can point exactly, or reasonably exactly. And in fact, I'll have the 7 here as well. 6:20 is going to be a third of the hour hand's going to be a third of the way between 6 and 7. I'm sure you're getting the hang of this by now. So let's draw our line up here. So this here, we've got 2 lots of 30 degrees, which means that this is 60 degrees. You can just write that in, knowing that this is 60 degrees is fine. And this here, again, you know that that's 30 degrees, and you know that 20 minutes is a third of an hour, so we have gone a third of the way through 30 degrees. So a third times 30 equals 10 degrees, and that's what's in there. 60 plus 10 does indeed equal 70 degrees. So the answer is 70 degrees. No, it isn't. Always make sure that you're answering the question. The question asks, at what time? We already know that it's 70 degrees. So make sure that you write nice and clearly 6:20. And that's your answer. We don't know whether it's AM or PM, it doesn't matter, it isn't specified by the question. Right, okay, this is great, I hope. I hope this is useful, by the way. You might not encounter these specific questions in an exam, but clock problems of some kind are very common. And so the basic principles here, it's very important to get the hang of them. I think to recap, beg your pardon, goodness me. I think to recap some of the most important ideas here are, first of all, having an understanding of what some common angles are. Know that a right angle is 90 degrees, know 180 degrees, know that a one number, as it were, on the clock face, so 12 o'clock to 1 o'clock, for example, is always 30 degrees. If you know those things, that's a really, really good start. One of the really common mistakes is moving the minute hand, but forgetting that the hour hand moves at the same time. So that's a very important thing to bear in mind. Break everything down and work really systematically with a really good sketch of the clock face. Make it nice and big, but it doesn't need to be accurate. It doesn't need to include the whole clock face. Write in your lines and start filling in the gaps. If you don't have space, draw arrows into the gaps and write your working out at the end of the arrows. All the kinds of things I'm doing They will enable you to get through even the hardest of these with quite a lot of ease. Okay, this question here, I think I am actually going to skip this for the moment because it's really similar to the ones we've just done, and I don't think we're going to have time to do it properly. So instead, I'm just going to tell you the answers because if you've done the worksheet, you're going to want to know them. So 8A, the answer is... Oh, 8A, you draw it in. Sorry, that doesn't have an answer. Well, you draw it, but I'm not going to do that now. What's the angle? The angle between them is 22.5 degrees. Right, enough of that. Let's do something a little bit more interesting. Okay, so this is another similar kind of question to the one we've just done, but it requires just a tiny bit more thought, perhaps. Fortunately, we're told, well, let's read it out. Who wrote this question? I only get out of bed when the minute hand points to past, and the angle between the hour and minute hands is 105 degrees. What are the 4 times of day when I can get out of bed? Like most maths questions, this is not a very plausible scenario, but we just go with it, quite apart from the English. Right. Yes, thank you, the chess player 21. I did write only twice. What can I say apart from to beg for your forgiveness? Right. Okay, this person only gets out of bed at very specific times a day. When the minute hand points to past, that is an enormous help because it limits our options so much and it gives us a really straightforward starting point. So let's draw a clock face and let's draw a minute hand that points to past, and that is always going to be pointing there, so that really makes our life a lot easier. Now we need 105 degrees. So if we draw a line over here, pointing towards would be 3 on the clock face, and let's do another one over here, pointing towards would be 9 on the clock face. These have been right angles, and that of course means 90 degrees, except that it looks like I've done 40 degrees, so let's not have that. There we are, 90 degrees. I don't know why I've done it at a slant, but such is life. 90 degrees to 105 degrees. 105 minus 90 equals 15. We need another 15 degrees, okay? Right, let's think about this. So let's do a 2 up here. Let's just draw a line to that. So you can tell intuitively it's going to be somewhere between 2 and 3. Now remember, the distance between two numbers like this on a clock face is 30 degrees. Just avoided thumping the microphone like this, which would have been very annoying for you. It's probably been booming away as my elbows touch the table anyway. I'll probably listen to the replay of this and be despairing, but never mind, that'll come later. Okay, so 15 degrees, if this is 30 degrees, 15 degrees, as we know so well, is of course half of 30. We'll just write that note to show to our lovely examiner that we know what's going on. So we can put another line in here, and that's going to be 15 degrees, and that is going to be halfway between 2 and 3. So in fact, that is going to be, hang on a sec, I'm getting carried away here. Let's check it. 90 plus 15, of course, is 105. So this is what we want. So this can be our hour hand here. 90 degrees plus 15 degrees is 105 degrees. So the time we are talking about is, drum roll, 2:30. Okay. But hang on, we need the 4 times a day when I can get out of bed. The other one is going to be the exact mirror over here. It must be. So that's going to be 9:30. Let's just do the 15 here to show to any marker that we weren't just guessing. So we got 2:30 and we've got 9:30. But that is only 2 times. Or is it? Because of course, a clock rotates twice in a day. So we've got 2:30 a.m. and 9:30 a.m. and we've also got 2:30 p.m. and 9:30 p.m. Because I like underlining answers and it makes things clear for you checking back. Let's just do that. There we are. Okay. Simple as that. Not too complicated. The complicated stuff is coming up. Oh, yes. I must say, I thought about this one. I thought, how am I going to show this on the screen without taking hours and without making an absolute mess? Let's find out whether I can. Now, this may look like a really simple question, because you might say, for example, that at, what would be a really good example? At 6 o'clock, the minute and hour hands form a 180-degree angle. And you might say that at something like 1:35-ish, the minute and hour hands form an 80-degree angle. In other words, it's moving around like that, so it must happen once every hour. So in 24 hours, it must happen 24 times. But you've been given quite a lot of working space here. Things are not always quite that simple. So you need to run up a bit of elbow grease, actually working it out and finding out whether there's a catch somewhere. Let's do that. And luckily for you, it's me who's got to do the work. Some real elbow grease in this furnace of a room. It's getting seriously hot. If I keel over, wake me up with some sharp comments. Someone's saying in the comments, I'm so confused, can you repeat? I don't know time well. If you aren't very comfortable with time and we're telling the time on the clock, then what I strongly suggest is that you probably stop this here and that you do some work on getting used to clock faces and how to tell the time and how time works. And there'll be lots of other good YouTube videos on this out there, I have no doubt at all, and your friends and parents will be able to help you. Don't be embarrassed to ask. And then when you feel confident with that, maybe go back to the start of this video and then watch it again, because it'll make a lot more sense. I can't really explain how time and clock faces work here as well, because then we'd be here forever, which is a risk anyway, and I'm going to die of heat stroke within about 10 minutes. So let's have a look at this and let's go through it carefully. Now, of course, in a 24-hour period, we go around 2 rotations of a 12-hour clock. So if you can work out how many times this happens in 12 hours, we're just going to need to double it. So let's start off with the first one. So in fact, yeah, let's do a big clock face here. So we're going to have 12, you'll see why it's big in a bit. 12, 6, 3, and I'm making it as accurate as I oh no, disaster. What happens is if I accidentally touch the screen with my hand before my pen touches it, it slides around. And that is what happened there. 1, 2, 3, this is what I'd be fast forwarding if this was a pre-recorded video, but it isn't, because you've got the sad, where am I going with this? I'm just saying you're unlucky enough to be watching live, so I can't fast forward. And you can't slide past my waffle. Okay, so what's the first one going to be? Well, we can see straight away the first 180 degrees. It's not going to be 12 o'clock, is it? Because then you'd have both hands pointing up there. And of course, it isn't going to be 12:30, because that isn't a time, because the hour hand would actually be pointing over here. So it's going to be something just after 12:30. Something like this, and this. Roughly, we're just sketching. We don't need to know exactly what that time is. We just need to know that it exists, because our challenge is to find how many times there are. So that's one of them. And I'm going to put a little note here that says, I'm going to call that 1 and 1. Okay? And then between 1 and 2, so there's going to be something that's a little bit later on. So it's going to be something like, I don't know, 1:30-something-ish, maybe. 2, and we'll call that 2. I'm putting in a circle so they aren't confused with the numbers on the clock. I'm labeling both ends because when we've done some more of these, it's going to be quite confusing to find our way around. Okay, the next one is going to be a little bit further on. It's going to be 2 and a bit more. So it's going to be something like that. Again, we just need to know that these exist. We don't need to know exactly what they are. It's going to be 1 over here, 3 something. And this is actually quite quick to do, and if this is probably a question that's going to be worth 4, 5, 6 marks in an exam, so you can afford to spend a little bit of time on it quickly doing this. Right, and then we're going to have something between 4 and 5. Now this one is going to be with because 5's down here, it's going to be somewhere up there, isn't it? If it's going to be 180 degrees. So again, we point that down there, and we point this somewhere up here. 5 and 5. Okay, and then what's between 5 and 6? So if you have something that's about 5:30, now hang on, the two hands will be together. If we have something like this, so it's there and it's nearly 6, but that doesn't, hang on a sec. The only next one that works is 6 o'clock. Six and 6. By the way, I should explain this rather than just taking this for granted. Well, I imagined one that was like that. That can't be the case. We can tell that deductively by looking at what's going on. We can see that each of these is roughly an hour around the clock face. So two right next to each other like this will be very bizarre. How could that happen? How could we have 280-degree angles right after each other when we know that the hour hand and the minute hand is moving faster than the hour hand? It isn't possible. They'd have to be moving at the same speed for that to work. If that doesn't make sense, I'm not going to hang around to explain it more because we'll run out of time and there's another tricky question to follow. Sorry, just rubbish teaching. Right, okay, 6 o'clock is our next one. And then, by virtue of the same logic, there isn't actually anything between 6 and 7 because as we move the hour hand on, I'm trying to show with my hand, I'll show my hands over here because then you can see. As we move the hour hand on slowly, the minute hand goes faster. So look, this is the hour hand down here, this is the minute hand. So as we're going between 6 and 7, the hour hand's going round, but the minute hand is going faster and faster. And it's going round and round and round. Oh, and it's going round and round and round. And you see we've got all the way to 7 o'clock and still there hasn't been a 180-degree angle. So we're going to have to go past there to something like that. Which means that, did that make sense? I hope it did. So we're going to be something just after 7 o'clock. Okay, it's number 7. We're nearly there, by the way, don't worry. Not going to be too much longer. Okay, and you might be able to notice that we're actually mirroring. So these two are mirroring each other. We're having the same things going on, going around the clock face here. So there's one between 7 and 8. There's going to be another one between 8 and 9. There's going to be another one between 9 and 10. What's it going to be? It's going to be this side of it because we're not past past yet. So that's 9. Another one up here. 10. And finally, another one like this one here, which is going to be something like this. So there are 11 of them, and there are 11 of them because at 6 o'clock down here, that that number is that 180-degree angle is doing the job for the 5 to 6 o'clock area down here and the 6 to 7 o'clock area down here. So it's doing two jobs in one, which is why we have 11 in total and not 12. Now this is a 12-hour period, so for 24 hours there are going to be 11 of these times 2 equals 22 times that this happens. So there are 22 times in a 24-hour period that the minute and hour hands form a 180-degree angle. And I hope that makes sense. It's tricky. You might need to watch that a few times to really get the hang of it. Someone says, why does it say in the description that this week's lesson focuses on written comprehension skills? It must be that when I started the stream, I still had the video description from last week in the stream settings. I'll adjust that once the lesson's over and I can change that on the video. But thank you for pointing it out. It's the kind of thing that happens when you're doing this. I'm not going to get too stressed about it. Right, okay, this is the Big Daddy question. And the one that I'm sure you've all been waiting for. And as I said before, if you hadn't had a go at this yet, then print the sheet off, have a go, and then restart the video or come back and watch it again. Okay, let's go straight on. I was going to pause to the tip of the week, but actually let's just power through while we're doing this maths before too much time passes and I collapse. Clock A and clock B are both 12-hour clocks. So what that's doing, it's just telling us we're dealing with the same kind of clock we've been dealing with earlier. Okay, but these clocks are faulty. Clock A gains 10 minutes per hour and clock B loses 5 minutes per hour. Okay, what does that mean if a clock gains time in an hour? It means, there's another way of saying that is that it's fast. So for example, at 12 o'clock, if you start the clock accurately at 12 o'clock, it'll say 12 o'clock. But when it should be 1 o'clock, the clock will actually be saying 10 past 1 because it's 10 minutes fast. Each hour. 10 minutes fast means it gains 10 minutes per hour. Clock B is 5 minutes slow. So if you start clock B at 12 o'clock, when it's 1 o'clock, the clock will actually be saying 5 to 1. So it's behind. Now this is a kind of question. This is actually a kind of standard kind of maths question. If you Google faulty clock maths question, for example, you'll find lots of questions like this. And actually this one with 10 minutes and 5 minutes is a really common way of setting it up. It's not an original question from me at all. You'll find ones with 5 minutes and 5 minutes, with 10 minutes and 20 minutes. There are all kinds of versions out there. But the method I'm about to show you is always the same with minor variations for the type of question. One day at 3 p.m. they're both set to the correct time. I'm going to tell you now that the at 3 p.m. will not be relevant. It's just to give you a concept in your head if you want to have a starting time, but neither of these questions that are going to follow up ask us to give a time. So this doesn't actually matter. So I'll actually just get rid of that so it doesn't confuse us. One day they are both set to the correct time. How long will it be until the two clocks next show the same time as each other? Now this looks like an absolutely fiendish question because it might be months before they show the same time as each other. It's really hard to know. You've got one clock that's going faster and faster and faster and one's going slower and slower and slower. How can you find when those hands meet for the minute hands and for the hour hands, so they're showing the same time? Now I could go through trying lots of different things and showing you why they don't work. I'm going to be nice to you. I'm just going to show you the correct method. So let's imagine the end of 1 hour, okay? And let's just think about the minute hands for the moment. Let's ignore the hour hands completely. So when we start off, of course, both minute hands are going to be pointing up there. At 3 o'clock it was, both minute hands are going to be pointing to the hour. After an hour has passed, the minute hand of clock A, because it's 10 minutes fast, is going to be pointing over there. The minute hand of clock B, because it's 5 minutes slow, is going to be pointing up here. So after an hour, there is a 90-degree angle, but this is not an angles question. There is in fact a 15-minute difference. Dealing with time here, just with time. We're done with angles for today. There's a 15-minute difference between these hands after an hour. And that is the key information that we're going to use. Because 15-minute difference between these hands, but also there's a 15-minute difference between the time that these clocks show overall. Clock A has gained 10 minutes and clock B has lost 5 minutes, so the difference after an hour is 15 minutes. Now, let's think about how we can use that. What will it mean when these two clocks show the same time? Let's imagine two clocks that are showing the same time. Okay, so we got clock, let's imagine our starting time of 3 o'clock, even though that doesn't matter. So that's clock A and that's clock B. Just conceptually, here's A and here's B. So what do we know about the times on those two clocks? What is the difference between those times? Okay, so you're going to think this is a stupid question, but I want you to stop and think about it for a second. And if you're rewatching this, please actually pause the video while you think and come up with some ideas. Okay, I'm going to give you 10 seconds or so just to think about this. Okay, that's long enough. I can't pause for longer than that, or people will start logging off, if they aren't anyway. The difference between these clocks is no difference because they're showing the same time. But it could also be that the difference between these two clocks is 12 hours. Because if two clocks are showing the same time, one of them could be 12 hours different from the other, and it would show the same time. Or it might be 24 hours difference. Or it might be 240 hours different. They might be showing the same time, or they might really, in a way, be showing a time that is any multiple of 12 hours different. How does this help us with our problem? Well, these two clocks grow 15 minutes apart from each other every hour. They will next show the same time when they are 12 hours apart from each other, because that will look identical to them not being out of each other's times at all. That was a terribly constructed sentence. Don't come to me for English videos. Okay. Right. So what was I doing? Yeah, 12 hours. When they're 12 hours apart. Okay. So give me a second here. What am I saying? Right, they 15 minutes and 1 hour. So how many 15 minutes are there in 12 hours? Well, to be 1 hour apart, they'd have to do it 4 times. Okay, 60 divided by 15 equals 4. So they're 1 hour apart. Oops, that is not a T by any conventional definition. 1 hour apart after 4 hours, because that's 4 lots of 15 minutes apart. So to be 12 hours apart, 12 hours apart after 4 times 12 hours, which 4 times 12 equals 48. So the answer is that they will show the same time after 48 hours. Don't forget to write the units, hours, even if it looks like cows or whatever I've written here, you need to have units in there. So just to recap that very quickly. If one game's 10 minutes each hour and the other loses 5 minutes each hour, that means the difference between them increases by 15 minutes every hour. Don't worry if you're puzzled down there, I'm going through it again. Okay, 15 minutes difference between them every hour. That means in 4 hours, there'll be a 1 hour difference between them. 15 goes to 30, goes to 45 minutes apart, goes to an hour apart. So after 4 hours, they're 1 hour apart. We know they'll show the same time when they're a whole 12 hours apart, because that's the same as not being apart at all on a normal clock face. So we just need to times that by 12 to give us 48 hours. William Kyler, Year 5, do not be sexist in my lessons, thank you. Let's go on. How long will it be until the two clocks both show the correct time once again? Okay, this is a really, really, really horrible follow-up question, it looks like, and it's likely to be very confusing. But the good news is that once you know how to do it, you've really cracked the hardest kind of clock problems that ever turn up in 11 plus. And yes, these questions do occasionally turn up in 11 plus. I have seen them rarely in past papers, so this is not just theoretical. Yes, commenter, I am aware that there is a wrong description on this video because it's copied across from last week's lesson. I'll correct it afterwards. This is not a written comprehension lesson, this is a maths lesson, as you may have worked out, intelligent as you are. Okay, how long will it be until the clocks both show the correct time once again? Right. Now, we know that they will show the same time again after 48 hours. But will that be the correct time? Well, clock A gains 10 minutes per hour. That's a sixth of an hour. So clock A is plus a sixth of an hour per hour. Okay, sorry about my writing of hour, it's truly horrible. So after 48 hours, clock A will have gained, it will have gone ahead by a sixth of 48, which is the same as 24 divided by 3, which is the same as 8 hours. So clock A will be 8 hours ahead after 48 hours. So it will not be showing the correct time. Clock B, we know, is showing the same time as clock A after 48 hours. So if clock A is 8 hours ahead, clock B must be 4 hours behind, because these two add up to 12 hours. Don't worry if that isn't that clear. You don't actually need to know it. Really, it's just a useful thing to bear in mind if you want to have a good, clear mental image of the question. Why am I underlining this? It isn't the answer to the question. Okay, so it's 8 hours ahead. If they're going to show the correct time, it either needs, and now we're back to the principles from the first question, it either needs to be 12 hours ahead, or a multiple of that, 24 hours ahead, 36 hours ahead, or 48 hours ahead. Does that make sense? Sorry, I'm dying of heat here, that's why I'm babbling. I'm actually going to turn the fan on. I'm sorry if this makes an annoying hiss in the background, but I'm not going to be able to get through the rest of this otherwise. Right, the temperature's like 40 degrees in here or something. 12, so we know that when a clock is 12 hours fast, it's showing the correct time again. And we know when it's 24 hours fast, it's showing the correct time again, and so on. That's all I'm trying to illustrate here. So after 48 hours, so I'll put a little table here, hours, time ahead. I'm not bothering about clock B here, because after any multiple of 48 hours, we know they're showing the same time. I could do this with clock B instead. I could do the same kind of calculation. I don't need to look at both. So after 48 hours, we know that clock A, I feel so much better with the fan. We know that clock A is 8 hours ahead. Okay? That isn't a multiple of 12. Let's try again. After twice that, so 96 hours, it's going to be 16 hours ahead. That still isn't a multiple of 12. Okay, next one. After 144 hours, you could do these additions on the side. I'm just speeding through to save your patience. The time ahead will be another 8 hours. So it'll be 24 hours ahead, and that is a multiple of 12. So the first time, we know that, just to recap this, we know that the clocks show the same time as each other every 48 hours, which is when the difference between them is 12 hours, so they show the same time. But we know that after the first 48 hours, they're showing the wrong time. They're showing the same time, but it's the wrong time. After another 48 hours, they're still showing the same time, that's the wrong time. But after another 48 hours, they're showing the same time, and that time is 24 hours wrong, which means that on our clock face it looks like the right time. And that's the answer. So it will be 144 watts, minutes, no hours. Always write the units. And that's it. That's the answer to the question. Someone says, who disliked? That's a very kind of you to say. I suspect that the person who disliked the video is somebody who feels that I'm speeding through a lot of fundamental things without properly explaining them. And I think that's always the difficult balance for something like this. If you're going to explain the questions properly, you have to take a certain amount of basic knowledge for granted. And that can be frustrating for people who need to work on that basic knowledge a bit more, which is, there's nothing wrong with that. You're entirely free to dislike the video, but what I'd suggest more is that you go back and work on that basic thing you aren't quite confident with yet, and then maybe come back to the video when you've got that basic knowledge, and then maybe you'll understand what I'm saying, hopefully, if I've explained it half competently, which is open to doubt. Even if you dislike the video, please subscribe. I'm shameless. Okay, let us push on. I need to remember what my tip of the week is. Oh yes, this is a nice simple tip of the week, but very useful. Let's hope we haven't had it before. So So this week's tip of the week, nice and simple. When you're revising maths, you're going to start doing timed practice at some point as the exams grow near. And if you're like most people, you're probably going to find out that at certain points you get frustrated with the fact that your times don't improve, or that your marks go downhill as you speed up, because you make a lot of mistakes. When you're doing time practice and you start to encounter timing problems, don't try to solve them just by powering through and working faster and faster. Slow down and work out where in the paper you're losing time. And what you'll probably find out is that there's a small number of kinds of thinking. So, for example, thinking involving fractions and parts of things. Or, for example, your times tables are slowing you down, so when you do a long multiplication, it's slow. Identify those specific things that slow you down, work on them carefully, make sure that your core skills are really robust, and then take them back into time practice. And then when you find new things that slow you down, do the same things again. Deal with timing problems intelligently. Identify the roadblocks, sort them out, and then take that back into your timed work. But don't just bulldoze on trying to move faster and faster. It won't work. That's a bad way to learn timing. Okay, right. Final section. Let's briefly take a few the questions are not looking so useful. Hang on. Great, thank you, chess player. That's a good question. What if you don't have time to do longer questions, so you do the rest of the questions and want to come back to the ones you skip, but you don't have any time? Well, look, if you don't have time to do everything, then you don't have time. I mean, you're going to miss something out, right? I would say I wouldn't necessarily leave the longer questions, because a long question like some of the ones we've looked at here are actually part of other questions. And let's say you've been working on clock problems. There's a long clock problem question. That's a tongue twister. And then you do you think I'll skip it because it's long. You do lots of other maths, and then you come back to it. And by the time you come back to it, you've forgotten about clock problems, and you waste time re-remembering the maths. So if you think you can do the long question in reasonable time, I would do it at the point it appears in the paper. You need to think more in terms of time per mark, if that makes sense. So let's say that you've got a 5-mark long question. Can you do that as quickly? Do you think you'll do that as quickly as you would do 5 1-mark shorter questions? If you think it will take much longer than that, so it'll take you as long as, let's say, 10 1-mark shorter questions, then maybe you should think about skipping it, because you'll get more marks in the time by doing the shorter questions. But it might actually be the case that you'd spend less time on the longer question. What I'm saying really is time intelligently. Think about how to get the most marks across the exam based on how difficult you think a question will be, and use that as the thing that guides you. Don't just say, is it a short question, is it a long question? Oh, it's a long question, I'll skip it. That isn't a good way to go about things. The person who's writing thousands of times, hey Robert, do you like YouTube? I'm on YouTube. I'm streaming to you now. I like YouTube when it works, and lots of people benefit from these lessons. And I really hate YouTube when things go wrong with the streams, and it makes my life difficult. But broadly speaking, yes, I like YouTube. You can stop asking me now. Someone says, what is the next subject? I don't know yet. I haven't decided. I'm struggling to see all the questions because of all the do you like YouTube questions. How many hours of work or subjects do you suggest today? I actually answered that question, I think, last week or the week before, so I'll skip that for now, but I'll probably come back to it in a future lesson because it's a common question. You're going to teach line graphs. Yeah, I'll certainly be looking at graphs and charts at some point. Should you draw out a clock to help you, or does it waste time? I would recommend doing what I did, which is draw out the parts of the clock that you're going to use for that question. So, for example, if you're dealing with a time that's, 25 past 4, you're going to want to draw out that quadrant of the clock, that quarter, between sort of 3 and 6 o'clock. But you're probably not going to bother drawing all the numbers between 9, 10, 11 o'clock because they aren't going to be relevant. So just do it intelligently. Sketching's all about that. Be as accurate as you need to be for the kind of question. Please don't pose the same question loads of times because then I can't see everybody else's. What happens if you accidentally skip a page and then realise at the last moment? Well, if it's the very last moment, then you lose a lot of marks, don't you? Because you won't have time to go back to it. The intelligent response is to know that skipping a page is a risk and be ultra careful not to do it in the first place. Easier said than done. Will you have enough time to do trial and error in the exam? Well, if they set up a question where the solution is to be found by trial and error, then I think the examiner has calculated that you will. But I think the problem is in your term trial and error, because trial and error really means just throwing ideas at the page until something sticks. And that's why pedantic mathematicians are more likely to talk about trial and improvement. The difference is that when you use trial and improvement, you aim for something you think is likely. Then you think, okay, it was a bit too low. So you aim for something that's a reasonable amount higher, which might then be slightly above. And then you go between, and you work in like that until you zero in on the answer. And in an 11 plus test, a problem that you need to solve through trial and improvement, the answer is not going to be 146.312 degrees. It's going to be something reasonably straightforward, at least a whole degree, but probably nearest 5 or 10 degrees. So you'll get to the answer through trial and improvement if you do it intelligently, reasonably quickly. Right, probably last question here. Okay, a good question to end on from Demon Sleeper. I wish I was a demon sleeper. It'd be wonderful if I could just lie down and go. That'd be amazing. I'm okay as a sleeper, but sometimes I wish I could just drop off when I wanted to. So Demon Sleeper, I envy you. Right, I have a lot of stress knowing it is 2 months till the exam. Do you have anything that could make you feel a bit better? Well, I'm not going to give you a list of magic things you can do to revise more effectively in the last 2 months, because that's the kind of thing I've been talking about all lesson, and see all my other tips in the other videos. What I will say is it's just the 11 plus. If you're someone who is reasonably intelligent and you're hardworking and you get on with learning things that you need to learn, you will do well whatever school you go to. Don't get the idea that if you get into the school that you want, your life is sorted for you, and if you don't get into the school that you want, you may as well give up now because it's all a disaster. Life is not at all like that. So the main thing I would say with 2 months left is revise hard, but also relax hard and enjoy yourself. Take your work seriously, but don't get the wrong idea that your schoolwork is the most important thing in the universe. It isn't. You just need to do your best, and nobody can ask for more. And if you're somebody who does that, who works hard, who does their best, who gets on with it, then you will be fine wherever you go to school. So in your last 2 months, just don't worry. Take pride in the work that you do. You should feel genuinely proud of what you achieve and the things you learn. And the rest is out of your hands. And when things are out of your hands, it is not worth worrying about them. And that's all I've got to say on that. Okay, I hope this was useful. I hope you enjoyed all the maths we've done today, or at least some of it. I hope you learnt, if not. It's been lovely to have you here. Thank you for such energetic commenting. I've really enjoyed this one, actually. I hope I see you next Tuesday at 6 o'clock. Please like this video. Please click subscribe. Really, please click subscribe. And please click the bell button. See what I did there. And if you're watching on Facebook people, please pop onto YouTube and also click subscribe, because it really helps me to find new channel members. Because when more people subscribe, YouTube shows my videos to more people. It's been a pleasure. And I look forward to seeing you next week for a lesson on something or other. You'll find out.